welcome back to my YouTube channel, Massa Tutorials. Please do all to subscribe to this channel so that whenever I post any video, you'll be the first to receive it. Alright, we are still on our Analytic Geometry and Calculus, which is Math 102. Yes, mathematics for what? University students. So, Analytic Geometry and Calculus, we are on the subtopic gradient of a line. Gradient of a line. Gradient of a line. How do we find for the gradient of a line? Another name for gradient is the slope. The slope, or we can say the steepness. The steepness of a line. So, listen. Gradient of a line. The gradient of a straight line, also known as the slope of a straight line. Right? The gradient of a line, also known as what? The slope of a straight line. So it's also known as the slope. The slope of a straight line. So the gradient of a straight line, also known as the slope of a straight line, is a measure of the steepness. Is a measure of the steepness. Somebody can say it's the measure of the strength. The strength is the measure of the steepness of the line. So, what would be the strength of the line, or what would be the gradient, or what would be the slope, or what would be the steepness of that line? So, steepness means how an angle is falling or what? Rising. So, the meaning of steepness, how an angle is what? Falling. Is falling or what? Rising. So, we have what? An increasing function, then we have what? A decreasing function, or somebody can say an upward slope or what? A downward slope. An upward slope or a downward slope. So you can call this one a decreasing function. Then here you can call it a downward. You can also call it a downward slope, right? A downward slope. Here you can call it increasing, right? It is increasing. Then here we can call it what? Upward. Upward. So, upward slope. So, increasing, decreasing. Right. Alright, so let's see. The gradient is usually represented by the variable m. So, when you see this variable m, it's denoted as the what? The gradient. So, the gradient is usually represented or denoted by the variable m. So we denote this variable or letter or the alphabet by what? The gradient, right? We denote this letter or variable as the what? As the gradient. Now, the gradient of a line can be determined by the following from, now you can get the gradient from the following. Let's listen very carefully. Pay attention carefully. Pay rapt attention here. You can get the gradient from the following. If you want to find for the gradient, 1, you can get the gradient, which is m, or we can call it the slope of a line. The gradient of a line can be determined from so we have 1, any two given points, then 2, we have any linear relation, then 3, we have any linear graph. So the gradient m of a line can be determined from what? 1, any 2 given what? Points. So if they give you points on that line, right? If they give you any 2 points on that line, you can determine the gradient, the strength, the steepness, the slope of that what? Line. Then 2, any linear what? Relation. If they give you any linear relation, as in we have the general equation of that, which is ax plus by plus c, which must be equal to what? 0. So this one is the general equation of a what? Of a line. Or we can give you the slope equation form, which is y equals mx plus what? C, right? Y equals mx plus c, where m is denoted as what? The gradient. Then c will be the intercept on the what? On this y axis, right? Where the line cuts the y axis. So you can determine it from what? This c. So imagine if I have, let's say, y equals minus 2x plus 4. Y equals minus 2x plus 4. So let's assume that we have this line here, y equals minus 2x plus 4. How do we determine the gradient from this line? So that's what the question we are saying here, which is what the gradient m of a line can be determined from what? Any linear relation. So you've been given a linear relation. How can you determine the gradient from this linear what? Relation? So I can compare it with what? With a slope equation, which is y equals mx plus what? C, right? So when you compare this to that, we can say that y equals what? Y. Then minus 2 should be equal to what? M. Then we have x, which is equal to what? X. Then c must be equal to what? 4. So when you see it as that, then you can say that then m equals what? Minus 2. Then c equals what? 4. Right? So we have this. We can say that the gradient m is what? Minus what? 2. Then the c, which is the intercept on the what? On the y-axis, which is what? 4. Right? The intercept on the y-axis is what? 4. So now it means that where the line cuts the y-axis, so it means that the line cuts the y-axis. So let's denote here as y and let's denote here as x. Right? So if we have this, then it means that here is what? 1, 2, 3, then what? 4. So it means that this line, the line cuts what? The y-axis at point what? 4. So we have the y-intercept, which is 0, 4. So this will be the point for which the line cuts that what? Y-axis. So that's what we can as what? We can determine the gradient from what? Any linear what? Relation. We can determine the gradient from any linear what? Relation. Then 3, any linear graph. So you can draw a graph, or we can give you a linear relation, then we'll give you points, which is what? X and y. Then we'll give you values for x, then we'll give you values for y. Then use that table to draw what? To draw a line graph. Use that table to draw a linear graph for that. So if you use the table to draw a linear graph, then it means that you can determine the what? The gradient of that what? Line. Right? Alright, so the gradient m of a line can be determined from what? 1, any 2 given points. 2, any linear relation. Then 3, any linear graph. So that's how it is. So that's how it is. Alright, so let's continue. The gradient of the line AB is given by, so now watch here, listen. So we have this, the gradient m of a line can be determined from 1, any 2 given points, 2, any linear relation, 3, any linear what? Graph. So now, we consider a triangle ABC. 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 We consider a triangle ABC with coordinates A, x1, y1, B, x2, y2, and C, which is, we assume x2 then y1 for that, and C, x2 then what? Y1. and see x2 then y1 as shown in the diagram. So we show it here. So now let's see. The gradient of the line AB is given by, we can show it on the diagram here. Shown in the diagram below. So if you have the y-axis here, then you have the x-axis here, then our origin here. Then we have a value here on the x-axis, which is x1. Then a value here on the y-axis, which is what? x2. Then we have y1 here. Then we have what? y2 here. So now, you have a point here. Then you have another point here, right? So point B, which is x2, then y2, then point A. Point A, which is x1, y1. So as that, right? So now, then we have another point x2, y1. So we have another point here, which is point C, x2, y1. So x2, y1. So we can see that they form a right angled what? Triangle. So they form a right angled triangle. They form a right angled triangle. So now let's see. The angle created here is what? Theta, right? The angle created there is theta, because line AC, then line AB, they meet at this point. Point what? A, which is what? Theta, right? Theta. So now, let's find for the distance between x1 and x2. So the distance will be what? Will be x2 minus x1. Because when you visit our last tutorial, we said that if you want to find for the distance, we subtract the smaller value from what? The bigger value. So x1 from what? x2. So which becomes what? x2 minus what? x1. Then here too, on the y-axis, so this one is on the x-axis. So when you come to the y-axis, we subtract y1 from what? y2. So I have y2 minus what? y1, which is the distance. Then here the distance. So now, we want to find for the gradient. So how do we find for the gradient? How do we find for the gradient here? How do we find for the gradient? How do we find for the gradient? How do we find for the gradient here? Now, the gradient or slope of the line joining A and B is given by, so the gradient or slope of the line joining A and B is given by, so we can write it as M, because we know that M is the what? Is the gradient. So we can say it's equal to what? The vertical what? The vertical line all over what? The horizontal. All over the horizontal line. The vertical line all over the horizontal line, which is equal to, so we have the vertical line, which is this one. So which is equal to what? The difference in what? In the y values, right? So we can say that the difference in the y values, right? The difference in the y values all about the difference in the x values, right? So we can obtain what? The gradient, which is what? The vertical line. That's the vertical line. Then the horizontal line. So the difference in the y-axis all on what? The difference in the x-axis. So we can say that M must be equal to, which we have what? y2 minus y1 all on what? x2 minus what? x1. Which must be equal to, you can still interchange and get y1 minus y2 all on, make sure to bring here x1, not x2. So x1 minus what? x2, which must be equal to, now, we are finding for the difference. So we can say that the change in the y values all over what? The change in the x values, right? So we can use this or that for what? The gradient, right? You can use this, that, or that to find for the gradient of any line joining of any line joining 2 points, right? So if you have 2 points, then it's connected by a line segment, then you can find for the gradient, the strength, the steepness of the line. So now we can say that the gradient of the line AB. So the gradient of this line, how do we find for the gradient of this line? So the gradient of this line AB is equal to y2 minus y1 all on x2 minus x1, or y1 minus y2 all on x1 minus x2. Also, since we have a right angled triangle, by using the trig identities, the gradient of AB can be written as AB is equal to tan theta, right? By using the trig identity, we can say that AB is equal to tan theta. Why is it tan theta? You know that tan theta is twa, which is opposite adjacent. So where this angle faces is the opposite. So I get y2 minus y1 all on adjacent. Where's the adjacent? This is the adjacent. Where the 90 degrees faces is the hypotenuse. So I have the adjacent, which is x2 minus x1. So we can say that this tan theta is equal to that. And this tan theta is the same thing as the gradient, right? So you can use that to represent that. So if you get, and if they ask you to find for the gradient of 2 points, and that 2 points is connected by a line segment, then the formula you use is m equals y2 minus y1 all on x2 minus x1, or y1 minus y2 all on x1 minus x2, or we can say that the change in the y values all on the change in the x value. So watch it very carefully. Alright, so let's proceed. Let's look at these diagrams very carefully. Now, if a linear graph is drawn, per the linear graph, you can determine whether this one is an upward slope or a downward slope, or it has no gradient, which is zero gradient. Now let's see. If you have something like this, so we have an increase here, so we'll get a positive gradient, which is an upward slope, right? An upward slope. So we have a positive gradient. Then we have this which is decreasing, right? It is decreasing. So this one, it will give me a negative gradient. So that's a downward slope. Then if you have a vertical line, so this one we have no gradient, which is zero gradient, right? You can represent it as zero gradient. So no gradient here. Then horizontal line here. Horizontal line. Here also we have zero gradient. There is no gradient here. So vertical line and horizontal line, there is no gradient. But here, the strength you use in climbing this, or the strength a vehicle uses in climbing this, it will be will apply more force here. Can apply more force when you are climbing this, right? But when you are declining, or when you are coming down, then the force you use here is not the same force you use here. Now, the force you use here is not the same force you use here, and the force you use here is not the same force you use here. Bear in mind, here when you are climbing, it's not easy. But here when you are descending, it's very, very easy. Here, is horizontal, right? So now here, so when we are there, you are there. But here you can never be still here, because when you are still here, you can descend. Here, when you are still here, you would descend, right? So take note of that. It's very, very, very important. So if you have an increasing function, that's what a positive what gradient or an upward slope, then that means what the gradient is what is positive. Then when you have a decreasing function, then it means that the line of that gradient is what the gradient of that line is what negative. Then here to horizontal line is what 0. Then vertical line is also what 0. So please take note of this sketch very, very well. Alright, so let's see. So that's that. So this one, the line is rising from what? Left towards right, which is what? Increasing or upward slope. And this one, the line is falling from what? Left towards right. So it's falling from what? Left towards right. So take note of that properly. So now, so now let's see. Let's see how best we can solve this. Let's see whether we can solve more examples here. Let's see whether we can solve more examples here. So now, so let's start with the solution. So now let's see. Find the gradient. Of the line joining point A 4, -3, B -2, -1. So this one, how do you find for the gradient of the line joining point A 4, -3, B -2, -1? How do you find for the gradient here? Now, solution. Let's see how we can find for the gradient. If you want to find for the gradient of 2 points joining what? A line, then we can say that we quote our formula, which is m, the gradient of what? Line AB, right? The gradient of this line AB, which must be equal to y2 minus y1 all on x2 minus x1, right? So we have x1 y1 here, then x2 y2 here, right? So m equals what? The line AB, which must be equal to y2 is -1 minus y1 is what? -3 all on x2 is -2 minus x1 is what? 4, right? So I have -1 plus 3 all on -2 minus 4, which gives -1 plus 3. -1 plus 3 gives what? 2. All on -2 minus 4 gives what? -6, right? So I can say that the gradient of line AB is equal to what? -1/3. Because 2 goes into itself 1, then into 6, 3. So I have -1/3. So now we have a negative gradient. Then that means the linear graph will be what? Will be decreasing. So that's a negative gradient. So this one will be the line. This will be the line. So I have point A for -3, then point B -2, -1. So this will be the what? The linear graph. This will be the line. It will be a decreasing function. For that to be a decreasing line. Alright, so watch it very carefully. All right, so let's see next example. Let's see next example. Let's see next example. So let's see. It said find the gradient. Find the gradient of the line. 7x plus 4y plus 2 equals 0. And its intercepts on the x axis and y axis. So find the gradient of the line 7x plus 4y plus 2 equals 0. So that's one question. And its intercept on the x axis, 2 questions. Then y axis, 3 questions here. So how best can we solve this question? So now we have the line 7x plus 4y plus 2 equals 0. How best can we find for the equation of this line? How can we find for the equation the gradient of the line? How best can we find for the gradient of the line? So if you want to find for the gradient or the slope of this line, then we must first represent it in the form y equals mx plus c. We must let this be in this form. This one is the general equation, right? And this one too is the slope equation. So you must change this to be in this form. So that means you have to make y the subject in the line here. So you have to make y the subject. So we make y the subject here. Make y the subject of the equation. So I have 7x plus 4y plus 2 equals 0. How can we make y the subject? By saying 7x to the right hand side and positive 2 to the right hand side. So I have 4y being equal to minus 7x minus 2, right? Then again? We divide both sides by the coefficient of y, which is 4. Divide both sides. So here I have 4y divided by 4. Here minus 7x all on 4. Then minus 2 all on 4. Right. So this one cancels. So I have y being equal to minus 7 on 4, x minus 2 on 4, which is half. So I can divide that. So I have this. So now we can say that this is in the form y equals mx plus c. It's in the form y equals mx plus c. So we can say that m, which is the coefficient of x, is m. So the coefficient of x is m. So I can say that therefore m equals negative 7 on 4. Negative 7 on 4. So negative 7 on 4. So now we can see that they've given us the equation of the line, and we are determining the gradient from that line. Very, very simple. So if they ask you to find for the gradient given the equation of the line, make sure to represent, or make sure that you have to send it to the form y equals mx plus c, or to make it in the slope equation form, right? Make y the subject, then you are gone. Then find for the coefficient of x, which is m. So the coefficient of x will determine the gradient of that line, right? So now the gradient is minus 7 on 4. Then now they said we should find for the x-intercept. So the x-intercept, if you have x-intercept, then y must be equal to 0. For x-intercept, y must be equal to 0. Y must be equal to 0. So I have any equation you pick, you go through. You can pick this, you can pick that. So if I have y equals minus 7 on 4, x then minus half. I want the x-intercept. So x-intercept, I place y equals 0. So here y equals 0 being equal to minus 7 on 4x, then minus half, right? So now I make what x the subject. So I send this one to the left hand side, so I get 7 on 4x equals what? Minus what? Half, right? Then what do? The LCM is what? 4. So I multiply by what? How many times? 2 times. So I have 4 times 7 on 4x equals 4 times what? Minus what? Half. So this one cancels. 2 here, 1 into 4, 2 times. So here 1, then I have 1 times 7x, which is what? 7x equals 2 times negative 1, again negative 2. Then what do? I divide both sides by the coefficient of x, which is what? 7. So I get x being equal to minus 2 on what? 7. Right. So now, if you want, they said they want what? The x-intercept. They want the x-intercept. X-intercept, we said y is equal to 0. X-intercept is not this. X-intercept is a point. So please take note. So therefore, x-intercept is what? Because y is 0, then x is what? Minus 2 on 7, then comma 0. So this is the what? X-intercept, not this. This is the x-intercept. So mind you, take note of that. This is the x-intercept, not that. Alright, so watch it very carefully. Alright, so they say we should find for the y-intercept. So how do we find for y-intercept? So let's see. How do we find for y-intercept? So if you want to find for y-intercept, which is x equals what? 0. So y-intercept, I have that, which is y equals minus 7 on 4x, then minus half. So if x equals 0, wherever I see x, I place in 0. So y equals minus 7 on 4, then 0 minus half, right? So minus 7 on 4 times 0 is what? 0. So y equals minus half. So I can say that 0 minus half is what? Minus half. So now, this is y equals minus half, but this is not the y-intercept. So now, you can get that, therefore, y-intercept is what? Because x is 0, so x 0, then what? Minus half. So this is the what? Y-intercept. Alright, so let's see another example. Alright, so watch it very carefully. We'll be seeing another example very soon. So, example 3. Example 3. Example 3. Example 3. Given point A, negative 3, 5, and point B, 5, negative 10. Find the slope of AB. How will you find for the slope of this AB? How will you find for the slope of AB? How will you find for the slope of AB? So let's proceed. So we have the point. So m should be equal to what? Y2 minus y1 all on what? X2 minus what? X1, right? So I have x1, y1, then x2, y2, right? So m should be equal to y2 is what? Y2 I have it as negative 10 minus y1 which is what? 5. All on x2 which is 5 minus x1 which is negative 3. So I have it as negative 10 minus 5 all on 5 plus 3. Right. So I'll get it as negative 10 minus 5 which is what? Negative 15 all on 5 plus 3 which is what? 8. So I can say that m is equal to negative 15 on 8. And we can determine the line. Because this one, the gradient is negative, then still it is what? Decreasing. So I have point A, which is negative 3, 5. Then point B, which is what? 5, negative 10. So negative gradient. Negative gradient. Very, very simple. You can watch it very carefully. Alright, so let's see another example. Let's see another example. It says find the gradient of the lines joining the following points. So we are find the gradient. Find the gradient of the lines joining the following points. Join the following points. So we have point A, CP, then C on P. Then we have CQ, then C on Q. So we have this. Find the gradient of the lines joining the following points. So we have this. How do we? So we have x1, y1, x2, y2, right? So now I have m, which is equal to y2 minus y1, all on what? X2 minus what? X1, right? Aha. So now m must be equal to y2 is c on q, right? Minus y1 is c on p, right? Then divided by x2 is cq. Right, then minus x1, which is what? CP. So, can go further and say that C on Q minus C on P, which is fractions, right? So, I can get what? CP minus what? CQ all on what? So, PQ in alphabetical order, PQ. All over CQ minus what? CP. Now, the reason why we had this is C on Q minus what? C on P. We do find for what? LCM because they have different what? Denominators. So I get what? QP. So in alphabetical order, which is what? PQ. So Q cancels what? Q, leaving what? P. So P multiplies C. So I'll get what? CP. Minus P cancels what? P, leaving what? Q. Q times C, which I'll get what? CQ. So that's it. So that's what we have there. Now, what do we do? This one is what? The division sign, right? So I can say that m must be equal to what? CP minus what? CQ all on what? PQ. Right. Then I have my division sign, which is divided by CQ minus what? CP. This one is all on what? 1, right? So we will change it to what? Multiplication. So I have m is equal to CP minus CQ all on what? PQ. Then times what? 1 on what? CQ minus what? CP. Right. So the whole of this cancels that. Right. So I have what? 1 on what? p q. So I can say that m is equal to what? 1 on what? p q. Since the gradient is positive, we can assume that we have what? An increasing function, or an increasing line, or an upward slope, since the gradient is positive here, right? So we can assume that we have what? An increasing function. So that's it. Kindly watch it carefully. All right. Let's move on to the next one. Point B. So we have point B. Question B, sorry. So I have this point, AP squared, then 2AP. Then I have AQ squared. Then I have 2AQ. Right. So this one is x1, y1, x2, y2. So solution here, I can get m is equal to what? Y2 minus y1 all on what? X2 minus what? X1. So y2, which is what? 2AQ. Right. Then minus y1, which is what? 2AP. All on x2, which is AQ squared, minus x1, which is AP squared. Right. So now, m, which is equal to, we can factorize 2a out, right? We can factorize 2a out at the numerator, because there is 2 here, there is 2 here, there is a here, there is a here. So we get 2a out, which will be what? Q minus what? P. All on, here, there is a here, there is a here, right? So I can say that a out, then I'll get what? Q squared minus what? P squared. I believe you are getting what we are doing here. There is a here, so we can what? We can factorize a out. Alright, so when we are proceeding, we can say that this one must be equal to, now, this guy can cancel this guy here, right? So I'll get what? 2, then what? Q minus P all on what? Q squared minus what? P squared. Right. Now, the denominator, let's see something. We can do something there. Now, the denominator, which is Q squared minus P squared, is difference of what? 2 squares. So this one, Q squared minus P squared, is the same thing as Q plus P, then what? Q minus what? P. Right. So it means that when you multiply this by that, then you multiply this by that, you have to get the results as that. Very, very simple. Q times Q gives what? Q squared. Q times my negative P gives what? Negative QP. Then P times Q gives what? Positive PQ. Then this one, I'll get negative P what? Squared. So this one cancels, leaving what? Q squared minus what? P squared. So it's true that this identity or this expression is equal to that expression here. Right. So we can use that. Right. We can use that. So I can say that m must be equal to 2 q minus p all on, I have what? Q plus p, then q minus what? P. So this one cancels that. Right. So I'll get what? 2 on q plus p. Then which is m must be equal to 2 on q plus p. So as simple as that. So kindly watch it very carefully. Alright, so let's see another example. Which is the C part. So you just pause the video, then you try this too, right? Just pause the video, then you try. So point C. So I have A cos theta, A cos theta, then B sin theta, B sin theta. This is the first point. Then the second point, A cos phi, right? Then B sin phi. So we have this. Pause the video and try. So how best can we solve this question? So now, solution. Let's see. So I have x1, y1, x2, y2, right? Wait. So the gradient, which must be equal to, you always quote your formula, y2 minus y1, all on x2 minus x1. So I can say that x2 is what? B sin phi minus y1, which is what? B sin theta, all on x2, which is A cos phi minus x1, which is A cos theta. So m, which must be equal to B sin phi minus B sin theta, all on A cos phi minus A cos theta. So we can factorize B out. So B out, then I'll get sin phi minus sin theta, all on, we can factorize A out. So A out, then I'll get what? Cos phi minus what? Cos theta. So we can leave it like that. We can leave it like that. So we can assume that this is our gradient for that. Leave it like that. Alright, so that's it. Very, very, very simple. Very, very, very simple. Very, very simple. So kindly watch it carefully. Alright, so I'll give you your home link, then you go and try these questions. If you face any difficulty, kindly WhatsApp me or kindly drop it at the comment section so that I can read your problem. Alright, so we'll end our tutorials here. So I'm giving you home link to try. Home link, home link, home link. So home link, question 1 for the home link. It reads, find all points, or find all the values of R such that the slope of the line through the points R4 and 3 minus 2R is less than 5. Then 2. Find the gradient m of the line 2x minus 4y plus 10 equals 0. And 3 find the gradient, or find the slope m, joining find the slope m of the line joining the points x, one whole number 1 on 3, then 4 whole number 1 on 2, and y -1, then negative whole number 2 on 3. So that's your home link. Kindly copy it well. Alright, we will end our tutorials here. Massa tutorials. Please do all to subscribe to this channel so that whenever I post any video, you'll be the first to receive it. Massa tutorials, made easy. Thanks for watching, then thanks for subscribing. I appreciate it. Thank you very much. Have a nice day. Bye bye.